Hi, friends! So it's midnight on Monday. It won't be Monday when I upload this, but it's Monday while I'm making this, so that's exciting. Today we're going to learn about how zip files are made, because that's what I'm learning about in computer science, and that's what I have to do tonight before I go to bed. So, it's going to be fun. It's not going to be at all like the time I tried to teach you about circuits. I promise it's going to be so much better. So this magical thing here is called a Huffman tree. It's just a fancy name. So usually when we write a file, each letter is represented by a string of zeros or ones, and there's 8 of them. So it might be like 0, 0, 1, 0, 1, 0, 0, 0. Yeah, so there's 8 characters. They're either zeros or ones, and the computer reads that grouping of 8, and it tells us what letter to recreate on the screen for you. But that's really long, because if you write like a 10-page paper, every single character in that paper gets encoded as 8 characters of binary, zeros and ones. So when you make a zip file that takes up less space, you do that by creating this Huffman tree. So basically, we did like a really small example. So the example we worked with, he told us had 2 A's, 5 B's, 8 C's, and 14 D's. So basically, A is used like the least frequently, so it needs to be the least accessible, whereas D is used all the time. So we're going to want to access D really easily. So we make this tree. So we start with A and B, because they're the smallest, and we pair them up. A is 0, B is 1. We could have switched it, whatever. So this whole little mini tree has a value of 7, right? Because altogether the A's and the B's are called 7 times. Then we combine that with the C's, and altogether that's 15 characters, because there are 8 C's, 7 A, B combined. And then we combine that with the D, which is used 14 times, altogether for a grand total of 29 characters, which is how many we had there. So that's super easy, because now, instead of D being represented as 8 characters, when we put this into the zip file now, the way that we're going to represent a D is we're just going to say 1. So that's the representation of D. So that's 1 character instead of 8 characters. So we just save 7 characters every time we type the letter D. And then C is the next most frequent, so we're going to go 0, 1, right? So that we know where to end it, because like nothing else is going to start with a 1 now. Otherwise we wouldn't know whether it was D or like some other character that was like ones and then other stuff. So C is 0, 1, right? And now nothing else is going to start with 0. That's still pretty short. That's a quarter of the length. Instead of 8 characters, we have 2 characters. So now nothing else is going to start with 0, 1, because otherwise how would we know if it was C or this other longer character? So to get to B, we're going to go 0, 0, 1, right? So that's how we get to B. It's 3 characters instead of 8, still saving space. And then to get to A, we would go 0, 0, 0. So those are now the codes for each letter. Instead of 8 characters every time we want to type one of these letters, it's 1, 2, or 3 characters. So that's super efficient for these letters up here. As you can imagine, the tree would keep splitting and splitting and splitting, and eventually you'd get to a letter that was probably about, 26 or 30, depending with whether you used exclamation points and periods and stuff like that. That would be significantly longer than the 8 characters, right? It would be like 26, because you split the tree too many times. However, since we used the ones that were the least frequent at the bottom and the most frequent at the top, it still saves us space, because the shortest ones, the most frequent ones, are so much shorter. So next week's project, we're actually going to compress them like that and do some math and figure out how much space they are actually saving us on average. So the cool thing about a Huffman tree is that every time you make a zip file, it makes a new Huffman tree based on your document. So it's not like, letter frequencies and whatever. It's like it makes a tree for your document, it encodes it using your tree, and then the file that you get stores the tree, how many characters in the document, and this new code for this new kind of encryption of the letters. And then using the tree and the sequences of zeros and ones, it breaks it back down into letters. So that's zip files. I hope that was much easier to manage. I think it was. This was my homework, to draw this tree. So that's fun. Anyway, I'm gonna go finish that now. Love you. Okay, bye.